Hi, I'm Dennis Pagano, Managing Director and Software Quality Expert at CQSE America.
And my name is Walid Maalej, and I am a professor of software engineering and software technology at the University of Hamburg, Germany.
And together we want to tell you the story of our paper, How the Developers Blog, an Exploratory Study, which we published at the MSR Conference 2011, including our ideas, the challenges, and the lessons learned.
Well, 10 years ago, if you look, for instance, at the conference proceedings, at the call for papers or the session names, this was certainly an exotic paper, since this community was mainly focusing on mining source code and version control repositories.
Today, 10 years later, we're extremely happy that it became the most influential paper in this community. Now, in general, this paper was among the first to study social media and software engineering. And when we talk about social media here, we do not mean your private Facebook or Instagram social networks. We rather refer to technologies that provide a lightweight mechanism to create and exchange information that are used by engineers in a work-related context. So, for instance, blogs or microblogs or code collaboration platforms. Now, back then, and I roughly refer to a time between 2009 and 2011, when we actually carried out the work behind this paper, collaboration platforms like GitHub or Stack Overflow that we know and use today, which basically really enabled social software engineering, they had just started. They were just in their infancy. Well, actually, Walid, do you remember how everything started?
Now, looking back and trying to align what happened then, back in 2008, 9, 10, 11, what happened in our minds, in our lives, I think this all started from two major observations, which clearly motivated this work. First, yes, certainly source code is the most important artifact in software project, and version control systems are thus perhaps the most important software repository. But clearly software projects are much more than this, much more than code. This is what we learned at the university. This is what we observed in our own lives, in our own work as developers, as engineers, working for industry, with industry. We clearly observed requirements data, user feedback and user input data, discussion data, rationale data, models and diagrams, documentation data, and of course multiple repositories for those data and for those artifacts. So all this belongs to the core of software engineering projects. So why did this all barely play a role at MSR? And maybe also in the open source communities.
Now, the second observation we made was a number of emerging trends in practice. Now, we'd just seen the arrival of the first app stores, which did not only allow users to download applications, but they also had a social media aspect to them. In that, they allowed users to rate applications and to provide public feedback, which could then be consumed by other users or by developers. Now, we also observed more and more blogs that were tied to specific open source communities. So a multitude of authors blogged about the same technology, the same operating system, the same programming language, and so on. Now, individual blogs had been around for quite some time, but now there were blog aggregators, such as Planet, which allowed open source communities like Apache or GNOME to collect all relevant blogs on a central page, Planet Apache or Planet GNOME. And these communities did not only include developers, but also other stakeholders, in particular users. Now, I remember vividly how we talked about this during one of our afternoon walks to the cafeteria. And we hypothesized, well, these blogs might actually contain some of the aspects of software projects that are not found in the source code. And actually, they are public. They have a history. And you know what? That makes them software repositories as well.
So these two major observations, they made us curious. And we kept talking and discussing about them during our ping pong session, our afternoon walks, our discussions and co-authoring sessions around the world. And yes, by then flying and traveling was quite common. And by the time we developed a bigger vision, which has two pillars. One, could social media actually fill the gap and become the modern way of a lightweight, continuous documentation and knowledge sharing in software project? And if yes, how? And second, could social media become a rich data source to understand and stimulate lightweight, continuous collaboration between developers and users? And if yes, how? This was clearly our bigger vision and our goal. And this MSR paper is one piece on which we worked toward this vision.
In this paper, we try to explore how social media and social media activities fit into the software engineering lifecycle. We would like to briefly introduce the three main research questions that we studied and point out some of our results. And please reach out to us if you have any questions or feedback when reading the paper, what we hope you will do, of course. And as we are 10 years older now, we at least want to try to give you some pieces of wisdom here and there. So we're also going to reflect a little bit what we learned during this endeavor.
So the first research question was about blog usage. That is, how the four open source community, the four software development community, which we studied in the paper, how do they blog and how do they share information in their blogs? We found that the four studied communities blogged frequently and regularly, actually 2 to 6 blogs or blog posts per day. And when looking at the differences between the blogging committers, so those who create codes, who commit codes, and on the one hand, and on the other blogging stakeholders on the other hand, so probably those who use the open source software and blog about it. When we're looking at these two target groups, we found that committers blog more frequently in our dataset and for a larger period of time than other bloggers. While blog posts were less numerous than commit messages, which we could also observe and collected in our dataset, blog posts comprised much more content. And actually, to our surprise, only 2% of the blog posts include source code. So the majority of blogs and blog posts that we had and what we analyzed included or provided rather a higher level information about the project and about the software. In about 30% of the posts, we found images, mostly screenshots, graphics, diagrams. But we also find community images of community events, for instance, like meetings and conferences, or even private images or private topics like vacation images on the open source community blogs. About 80%, so the vast majority of posts, includes URL, links to wikis, to other blogs, to issue trackers, to source code documentation, to source code. And we found that overall, committers, or blogging committers, shared, linked to, and reused more project knowledge than other stakeholders. Certainly these stats and numbers are interesting, yes, but I think what is even more interesting is how we arrived to those numbers and those statistics. For instance, certainly we did not distinguish between blogging committers and other bloggers right away from the beginning, top down. Also the distinction of the URL types and the image types and all the analysis related to that. And how this could tell us actually, or what this can tell us about knowledge sharing and knowledge sharing behavior was not right away from the beginning, as it reads in our paper and probably in many other papers. This is an exploratory work driven by some observations, a curiosity, and our vision. So the analysis and the reporting were truly iterative and incremental. actually as exactly we know from agile development. We start with a rough idea, small observations, part of the data. We phrase a question or a metric that we want to visualize the data, review the results and discuss these intermediate results, reformulate maybe again, more precisely, adjust the analysis, and perhaps try to get some more data and some more variables. For instance, whether the blog author has committed source code in this community or not. So here's our first advice to you, in particular to young researchers. Iterate over your analysis, discuss and review your intermediate results, and expand while doing the work, expand some attributes while discovering actually the interesting directions to go.
Our second research question was, what do developers blog about? So we wanted to understand which topics were published in blog posts, what's their prevalence, and what's their distribution. And initially, we didn't know how to approach this, but then we found a technique called latent dirichlet allocation, or LDA in short, that can be used to model the topics in a document corpus. And with LDA, a topic basically emerges as a set of words that are correlated with a certain probability because they occur in the same document. So basically, we had to create a corpus from the blog post for each community, remove the stop words, apply stemming, and then run LDA. But topic modeling was still relatively new, and I remember that tool support for LDA was not great. So I think I ended up having to run a Hadoop cluster on my laptop to make it work, or something bizarre like that, which I really wouldn't recommend as production setup, but as researchers, we have to be creative. Now, another challenge we faced was that the LDA algorithm needed to be given the number of topics it should find. So we actually had to experiment with different numbers of topics and manually look into the results to see if they made sense. And finally, we also needed to interpret and label the topics themselves. And again, this was necessarily a manual step. So the learning for us here was that automated methods like LDA are fundamental to cope with large datasets, but manual interpretation is as important, and it is accepted even in the MSR community. Okay, so let's briefly look at the results. We identified 23 recurrent topics and clustered them into 10 categories. And surprisingly, more than half of all blog posts discuss topics related to requirements, including application domain concepts and user interface design. So this was by far the most frequent topic category. It was followed by community topics and project knowledge, such as tutorials, API usage, and documentation. And we actually found that community topics were discussed orthogonally to other topics. But source code and other low-level technical content were far less popular than we had expected. And one possible reason for this level of granularity is that the blogs are actually directed towards the whole community.
Certainly the spice of this paper is the link between the blog data and the source code data or the commit data. So Dennis, this was actually the third research question, right?
Yeah, I agree, Walid. So in the third research question, we wanted to understand how developers' blogging activities relate to the other development work they carry out. More specifically, we were interested in two aspects here. First, do developers blog after having accomplished certain types of development activities? And second, is there a relationship between what they blog about and the actual work they performed? And a fundamental prerequisite to being able to investigate these questions was to associate the blog posts with the commit history. And we did this based on the authors. So we tried to map blogger names to committer names. And unfortunately, this was actually not as easy as it might sound. And the reason was that most blog posts include the real name of the authors, but most commit messages unfortunately only contain login names. So we had to use text similarity algorithms and also created login names from real names to be able to map the two sets. And again, this step required manual inspection and correction after the mappings had been created. But we now had a mapping between bloggers and committers that allowed us to focus on the blog posts that had been written by the active developers in the communities. We then ordered the commits and blog posts by time to obtain a sequence of events per author. Now, to study if developers blog after having done certain types of development activities, we classified each commit based on its commit message into one of four categories: forward engineering, re-engineering, corrective engineering, and management. And we found that developers are more likely to blog after corrective engineering and management activities than after forward engineering and re-engineering activities. And to further understand these patterns, we compared the actual content of the commit message and of the blog posts in these sequences. And interestingly, about 15% of the blog posts included information that had previously been described in commit messages. So why did developers blog after corrective engineering commits? Well, we concluded that they especially wanted to quickly share bug fixes with all stakeholders in the communities. And we actually found cases where developers even referenced the ticket number of the bug they had just fixed in their following blog post. Now, when publishing after management commits, developers seem to make the community aware of the overall project status, for instance, by announcing an upcoming release. And when we further analyzed the dependency between the commit message and what is described in blog posts, we found that it actually decreases with time. So, developers are more likely to publish information about their recent activities than about what they did in the past. Now, in hindsight, this research question in particular might suggest one important takeaway for freshman researchers. When we decided to mine social media as software repositories, we did something exotic. We broke new ground. But we also wanted to avoid to create an island here. Instead, we tried to build a bridge to the classic software repositories by connecting blogs and commits and investigating their relationship. So, it is important to think outside the box, but it can't hurt to link back into the box.
All right, so what happened after 2011, after we have published and presented this paper? Well, we clearly continued working on our vision to mine, extract, and use knowledge about software systems and software processes from lightweight, web-style, maybe social media documents. And second, to understand and support the interaction between the creator and the user of software. And indeed, studying software and its creator, and studying the user of software were actually happening in two different communities, two different research communities. The mining software repository on the one hand, so the creator of software, and the requirements engineering community, so the user of software. So in this decade, blogs were just one artifact that fits to our vision. Maybe the first, but just one. But soon, lightweight documentation and user-developer interaction were actually massively observed online in many other repositories, like in Stack Overflow, in tutorials, social media sites as Twitter, and perhaps particularly in app stores and app store feedback with the emergence of app ecosystem. We had several follow-up papers in these two areas, but this quickly become a very tiny small contribution, very tiny small fraction of a much bigger community and a much stronger work of others around these two very still vivid research areas. Lightweight documentation and knowledge sharing is software engineering. This includes mining knowledge and knowledge types from documents, recommender systems, authoring support, integration of all these documentation and life cycles, even generation of documentation. And on the other hand, analytics and software intelligence tools for understanding and supporting user-developer collaboration and user-developer interaction. And just to give one example here, in our own follow-up paper in Requirements Engineering conference in 2013, which actually got much bigger attention than this specific MSR paper, we actually found very similar pattern. We had conducted similar analysis and found very similar patterns on a different data sets. This was on app review data sets. For instance, that a new app release incites discussions and feedback, or some of the mineable topics, such as experience report or feature request, we could actually identify in both datasets.
So for me personally, this paper and its results form an important milestone. First, I was able to use it in my PhD thesis to derive a framework for continuous user involvement in software engineering. And second, today at CQSE, we use data mining in our tools to provide software engineers with a solid foundation for making the right decisions when they develop software in an ever-changing environment. Now, obviously, code and version control systems are very important software repositories for us, especially when it comes to maintainability. But we learned that for profound decision-making in software engineering, we need a holistic approach. We need an approach that takes into account all aspects of software. And therefore, we analyze and combine many other artifacts or software repositories, if you will. So that includes, for instance, test coverage, models, usage data, and of course, requirements.
Thanks, Dennis. I think this paper also, for me, it significantly impacted my work in the last decade. So after moving to Hamburg in about 2013 beginning, I built an own research group here with several successful PhD projects, PhD students, and in particular industry academia collaboration in these two areas, lightweight software documentation and data-driven requirements engineering. Actually also in teaching the methods and finding from these MSR papers and the follow-up research are now part of master level courses. So to summarize, when I look back, I see many other data sources now as standard software repositories. For instance, App Store data, release information, deployment and delivery data, social media data, and are now part of recent programs and recent calls and recent papers at MSR conferences. On the other hand, I see also topics like user and usage data monitoring, pragmatic requirements engineering, data mining techniques also becoming central, very central to requirements engineering. So it looked like both the mining software repository and the requirements engineering communities have grown together at least a little bit in the last 10 years and have certainly learned from each other. And this is really, really nice.
So I hope you enjoyed our story. Thank you all for listening and take care.